Hi, Living Environment kids. I thought today I would show you how to do the Catalase online lab. It can be a little tricky as we're trying to maneuver a couple of things, so I thought it would be a good thing to make a quick video. All right, so when you open up the document, you're going to click this link for the lactase enzyme simulator, and it's going to open up what you see over here on the side. Okay, the first thing is some pre-lab questions. And it says, read the information in the home and background tabs. Then, using your knowledge of biology, you can even use your notes. Some of you may not have encountered the notes that go with this yet, so this might be more of a pre-activity versus a post-activity, so it will depend. But certainly if you need to look something up, by all means, and you're going to answer the following questions. So when you go look at the home button, it's giving you a bunch of information. It's telling you what enzymes are, tells you what a substrate is. It gives you examples and things to look at down here, questions to explore. So it gives you kind of some information, right? Same thing when you hit the background link, it's going to tell you some other things. And you're going to literally go through, here's a picture here. It says, what is the enzyme in situation? You know that an enzyme always has an ASE ending. You're going to read through that and you'll see that. So there we go. We got lactase. What is a substrate in this simulation? Well, the substrate is the thing that comes into it. So lactose, an OSE ending. And again, you're going to draw basically the picture that's shown for you right here. Are you going to label it based on what you see over here? So you're going to kind of go through that preliminary part. Okay, explain how the structure of the enzyme relates to its function, and what is the technical term for the unfolding of an enzyme. And again, all of that should be in the home and the background sections. If not, feel free to Google an answer and check it out and try to get something. All right, so now we get to the simulation, and this is where I think people might have some trouble. All right, so you're going to hit explore, or I'm sorry, simulate. All right, and so now if you read the directions here, it says start with an initial lactose at 500 milligrams per deciliter and a pH of 7. Okay, so I've got 500 is already set, pH of 7 is already set. Do not vary these parameters while testing for temperature. They are the environmental controls. So as we learned in a good experiment, we're only varying one thing. And in this case, we're going to look at how temperature affects the functioning of the lactase enzyme. Remember, lactase breaks down lactose in our body. So if you are lactose intolerant, you do not have enough lactase to break that down. So if you can't eat dairy and milk and things like that, it's because you lack the proper lactase enzyme. Okay, it says be sure to show your instructor the method for calculating the rate of reaction. I'm going to show you how to do that so that can be a little confusing. It says vary the temperature by 20 degrees Celsius each round starting at 0. Run the experiment 5 times. So as we look over here, I'm going to bring the temperature down to 0. I'm going to hit run, and I'm going to hit run 5 times. 4 and 5. Okay, and so you can see that now all of that data shows up on my graph, or at least it should. I'm going to have to, sorry about that. I fixed it so now we can see it. All right, so again, I'm going to make sure that this is at 0, and I'm going to hit run 5 times. Okay, and you can see down here, it's showing up each time, and it shows you run 1 is blue, run 2 is red, run 3 is pink, 4 is green, and 5 is orange. You can see that they are at zeros for every single time. So here are my 5 trials, and it wants to know what the rate is. So when I go here and literally put the mouse over it, it's going to be able to tell me exactly what it is. Okay, what does it look like to you guys? Looks like 0. All right, so hold on, let me see if it'll be, there we go. Okay. So when you look at this, it literally shows you at the bottom, if you can see that the run is 0. Do you see what I mean when I click on it here? All right, so the run is 0. So at minute 3, which it shows you right here, which I can't move 2 things at once, unfortunately, but at minute 3 down here, it says the run is 0. So I know, and that's what I'm looking for. I'm trying to figure it out in, let's see where it says it right here. The reaction time for the first 3 minutes. So I'm looking at the rise over run or the slope, and it all calculates it for me. I don't have to be crazy about it. All right, so I'm going to put zeros all the way down because that's what it is. Okay, so the average obviously would be 0. Adding all 5 together and dividing by 5, it would be 0. All right, so I'm going to go back here and I'm going to hit 20 degrees. Okay, so now it's at 20. Oh, sorry, I should reset first so that, okay, so it didn't have the zeros there. So I'm set at 20 and I'm going to hit run. That's 1, 2, 3, 4, 5. Okay, and so the same thing now. I need to see the average at minute 3. So when I go and hold the mouse over minute 3. See where it says 3? Those are my numbers: 125, 161, 168, 178, and 207. So that's what I'm going to write over here now. So 125, 161. For the record, your numbers will be a little different. These are simulations for, like, all of them will be slightly different. So don't copy someone because you're going to need your own. 168, 178, 207. Okay, and we're going to do the same thing. So now we come back over here. We're going to hit reset. We're going to set it now to 40 degrees because I'm going up by 20-degree increments, and that's what it shows over there. And then do the same thing again. Run 1, 2, 3, 4, 5. Okay, and so again, I go to minute 3. It says 3 minutes. I got 225, 159, 241, 212, and 250. And that's what I'm going to record over here. I'm going to do the same thing for 60 degrees and then 80 degrees. And again, calculating the average as I go. So calculating that would be adding up the 5 numbers, dividing by 5 to get an average. I believe, does it say what you should round it to the closest for reliability of results? So I would say probably a 10th place, just to, be safe and make sure the numbers seem different. All right, now below you're going to make a bar graph. So obviously we know it's a little difficult to draw a bar graph, on this document. So you are welcome to create it on a piece of paper and upload it to Google Classroom. Or if your teacher specifically has instructed you to do something different, because I'm going to, give this to everyone, certainly you should follow along and do what they think is best. Okay, based on your data, what is the optimum temperature for the functioning of the lactase enzyme? So where does it function best? Okay. All right, next you're going to do it for pH. So when we come back over to our simulation here, all right, we're not really changing where we're going, but when we look here, it says the initial lactose should be at 500, the temperature at 25. Those are now our constants. So we're going to keep these two things the same, and we are going to change it here. And I'm going to do exactly the same thing. You're going to run it. 1, 2, 3, 4, and 5. Okay, and you can see again when I go to minute 3, there it is, it zeros all the way around. So I'm going to have 0, 0, 0, 0, 0, and the average would be 0. So you're going to do the exact same thing, pH of 4, 7, 10, and I believe 13. Okay, and then you're going to answer the questions that go with that. Okay, so again, making a bar graph, where do you see the best reaction rate? Okay, so I just wanted to kind of explain to you how to use a simulator, because I know it can be weird and it seems, confusing when it says to find the average. So I hope this video helped you to do it and to figure it out better. And if you have any questions, contact me if I'm your teacher or your teacher to make sure. Take care.